This is a question under the equilibrium of a force. It says if the rod AB is weightless, what force will be necessary to produce equilibrium and the position of the force? All the lengths are in centimeter. So we are given a light uniform object that is 100 centimeter in length. So this is 0, 20, 60, 100. And these are the forces acting on the object. We are asked to calculate the force that will keep this object in equilibrium. If you look at it, you will see 2, 2, and 8 Newton force acting downward. But only a 4 Newton force is acting upward, which means that single force that will balance this object should also be acting upward to balance the weight that is acting downward. If that is the case, then we need to introduce an upward force. But at what point will that force be acting? That position, we don't know. But we know that that upward force will be acting anywhere from A to B. But just by inspection, you will agree with me that the upward force should not be here because two forces are here and one larger one is here. So the upward force should be anywhere between this B and this 60 centimeter mark. So let's just arbitrarily pick a point and say let the force F, which we don't know the value, be at a position X from B, since all the dimensions are measured from point B. Now that we've done that, we are just going to take equilibrium of forces. By equilibrium of forces, we mean that all the forces acting downward must equal all the forces acting upward for the object to be in equilibrium. If that's the case, we have that 4 plus F for the forces acting upward should be equal to 2 plus 8 for the forces acting downward. From here, we can find the value of F. 4 plus F equals 12 because 2 plus 2 plus 8 is 12. So that F will be 12 minus 4, and that gives us the force to be 8 Newton. Now we know the force to be 8 Newton, but we do not know the exact position, X, where the force should be acting. To obtain the position X, we need to apply the moment of a force. You will agree with me that while taking the moment of a force or while applying the moment of a force, we take moment about a point. In this case, we can take any of these forces at a point as the point. But I am going to solve by taking moment about point B, about this 8 Newton force. If I take moment about point B, taking moment about point B, let's identify the kind of moment the forces will create. This force going up will cause this object to rotate like this. Taking moment about this point, this force will cause a rotation that happens like this. That is a clockwise movement. Similarly, the 4 Newton will cause a rotation like this about this point. If this is the turning point, the 4 Newton will cause a rotation like this. It's also clockwise. What it means is that these two will form an anti-clockwise rotation about point B. So 2 and 2 Newton force are forming anti-clockwise moment. We are not taking moment of the force of 8 Newton because it's at the turning point. The moment of a force about its own point is 0. So 8 Newton force, the moment of the 8 Newton force will be neglected because we are taking moment about B. Now that we've identified the clockwise and the anti-clockwise moments, we know that for an object to be in equilibrium, the clockwise moment equals the anti-clockwise moment. So let's start. For the force of F, the moment of the force of F is F times the distance x from point B. So we have F times x plus, for the 4 Newton force, it will be 4 times 20, the distance, and that is equal to the anti-clockwise moment, 2 times 60 plus 2 times 100. Remember, these are distances in centimeters from point B. Let's solve for x. F times x will give us 8x because F is 8. 4 times 2 is 80. 2 times 100 is 200. 2 times 60 is 120. So that 8x will be equal to 200 plus 120 is 320. If we subtract 80 from it, we have 8x to be equal to 240. Dividing both sides by 8, x will be equal to 240 divided by 8, and that is 30 centimeter. What it means is that the force we are looking for is 8 Newton, and that force is at the 30 centimeter mark of this light object. This is the answer, and it is very simple. I believe you enjoyed it. If you did, then here is a simple one on the next page. So this is the question. You have to find the reaction force P at O if the light object is in equilibrium. So we are looking for the reaction P. Please put your answer in the comment section, and thank you very much for watching this video.